Good morning, dear students. In the last class, we discussed all the terms related to the topic spherical mirrors. I explained you various terms: pole, center of curvature, principal focus, principal axis, and radius of curvature. Okay. Now, also we talked about in the previous class the convenient rays that we draw to complete a ray diagram. So let us recapitulate the same quickly in short, and then we will proceed with the today's topic. My dear students, there are three basic rays, three convenient rays. Number one, if the incident ray is aligned parallel to principal axis. If the incident ray is aligned parallel to principal axis, it always passes through the focus. Whether it's a concave mirror or a convex mirror doesn't matter. Second point. The second convenient ray is if the incident ray passes through center of curvature. If the incident ray is a line passing through center of curvature capital C, then the reflected ray will be the same ray with the opposite direction. Or I can say in this particular case, we will have angle of incidence equal to angle of reflection, which is 0 degree. Now the third convenient ray. If I talk about the third convenient ray, then it is if the incident ray is a line passing through the focus, which is just the opposite of first point which I just now said. If the incident ray is a line passing through the focus, then the reflected ray will emerge out as a line parallel to the principal axis. Now, out of these three convenient rays, any two we can use, any two, to get the image formation by either a concave mirror or a convex mirror. So, students, let's start today's topic. Chapter 5, Light Energy, and we are going to continue with the ray diagrams of the same. See students, today's topic is basically the ray diagrams, the main ray diagrams related to convex and concave mirror. If you remember, in the previous class, I told you that a concave mirror is the one that converges the light rays. There are two types of spherical mirrors. Concave mirror is the one which converges the light ray to at focus. They will all meet at focus, the reflected rays. Whereas a convex mirror is the one which acts as a diverging mirror. So what it does, a diverging mirror? Yes, it diverges all the rays. It spreads it on a wider area. Now we're going to talk about the next, that is ray diagrams of concave mirror. Starting with the first, let us consider that the object is placed beyond C. Okay, now this is point P, capital P. Okay, this is point P. Fine. Now, what is P? Can anyone tell me what is P? P is the pole, okay, which is the midpoint of this mirror. Which type of mirror is it? If the mirror is the one polished from the bulging part and the incident ray and the reflected rays, they are on the inside part, then it is a concave mirror, cave-like mirror. Okay, now this is pole, the midpoint of it, midpoint of the aperture. What is C, center of curvature? If I draw this imaginary sphere, complete sphere, of which the spherical mirror is a part, then the center of that is called as center of curvature. Half of that is the principal focus. So focal length is half of that, so that is the point where the principal focus, focal point is located. Okay, now if the object is beyond C, the first incident ray I'll draw a line parallel to principal axis. What will happen? As I told you, the reflected ray then will pass through the focus. This is how it will pass. Now the arrows are very, very important, my dear students. You need to draw these arrows without fail. Because most of the time what students do is they draw the ray diagram and this ray is missing. This arrow is missing. Because this arrow only tells that this is the incident ray because it's going towards the mirror. and which is getting reflected is this one coming out from after bouncing back. So now let's draw the second ray. As I told you, minimum 2 rays we need. So let the second ray now pass through focus. We know it's the opposite. So if the incident ray is a line passing through the focus, it will get reflected as a line parallel to the principal axis. This line is termed as principal axis, this white line which we can see. So now, can we see that the 2 points, can we see that the two meet at a point? Yes, the two rays, they meet at a point. So then the image formed we are going to see. Everyone keep looking at the screen. What do I do? And understand. See, my dear student, this is the point where the image is formed. And if I talk about the image formed, students, you can easily make out the point of intersection is the point where the image is formed, and we can easily make out, we can easily understand that what type of image is it. It's a real image. Which is a real image? Real image is one which is on the front. Then inverted, yes, if this was the image, then it is upside down, so it is inverted also. Smaller in size, you can very clearly see it was bigger the object, and the image comparatively is smaller in size. So my dear students, you'll give this as the heading: spherical mirrors, concave and convex mirror. Then the next heading, ray diagrams for concave mirror, as it is from the PPT. Okay. The next, first case you will write when the object is beyond C. You'll draw this ray diagram properly. Students, polishing the mirror is very, very, very important. Okay, because most of the time either the direction, these arrows are the mistake, the students do, or the labeling of these points which I have told you, or it is the polishing one. Because this silvered surface only defines a concave or a convex mirror. So without that, if this curve is drawn, 0. So this is how then you are going to draw the ray diagram. You'll write this way the position of object and then the image formed characteristic, the way I have written in the PPT. Let's move to the second case now. When the object is, now what happens is basically this object keeps on moving. Firstly, we placed it beyond C. You can see this ray diagram. The object was placed beyond C. Now I'm going to shift it and bring it closer. Slowly and gradually it comes closer to the mirror. So then the second will be, it will come at C when the object is at C. I'll discuss that also. Then the next, it will come in between C and F. The next between F and P. So like this, the object will be at F. The object will be at infinity. So these are the various cases, one by one we will discuss today. Let's talk about the next. When the object is, this is very, very important ray diagram, my dear students, very, very important. Okay, so you need not have to think of at all, ma'am, whether it is to be understood, done, or what, or what. Mind it very clearly, students. It is an important diagram and you all must do it. Okay, all of you must do it. It's an important ray diagram and you have to properly understand as well as do. Of course, all the ray diagrams have to be done, but this is again very, very important. Okay. Okay, this is an important ray diagram, so all of you must ensure that you do it very carefully. Okay, now what happens is when the object is between P and F, when the object is between pole and focus, see the students, the ray diagram, this is the image formed. Is it on the same side in front of the mirror? No, it is behind the mirror. So such an image which is formed behind the mirror is called virtual image. So that is this point is very, very important. The next is, what about the object and the image? Is the image formed erect or upside down? It is erect. It is no more inverted. So it is erect image, virtual because it is formed behind the mirror. And if I talk about the size, yes, we can very clearly see that the image formed is bigger in size. So such an image is called magnified image. Okay. So this is the only particular case. Why am I saying that it is important, my dear students? It is important for the reason that in this particular case only, when the object is between F and the pole, when the object is between F and pole, we can say, or F and mirror also the examiner can give it. Whenever this is the case, only in that case, the image formed by a concave mirror is virtual, erect and magnified. Okay, so now let us draw again two rays. First, let the incident ray from here, from the top of the object, you draw two rays. The first ray be a line parallel to principal axis. This is the ray. It will emerge out as a right ray passing through the focus. So we can see if this is the incident ray, it passes through the focus. Now second ray, if I have to draw to get the image formation, as I said, minimum two rays. So the second, let us draw a ray passing through the center of curvature. If the incident ray passes through center of curvature, what will happen? Yes, it will be the same ray retracing its own path. Let us produce now these two, because I know they are not actually meeting at a point. You can see the two rays. There is a gap in between. They are not meeting at a point. So to get the image here, we need to produce the two rays at the back, and the point where the two intersect, the two meet, there, that is the point where the image is formed. So why is it important? Again, I'm repeating because this is the only case of concave mirror ray diagram where the image formed is virtual, erected, magnified. The rest of the cases, the image formed is real and inverted. Okay, let's move further now. Concave mirror, there are various ray diagram, my dear students. See very carefully. See the arrows I have drawn, because without these arrows, 0, it was what the examiner will give you. Okay, so this needs to be taken care of. All the labeled points should be there. Everything must be done with the characteristics and everything. Okay, what is this here? This is the object. Object is greater than, that means beyond C. The object is beyond C. This I have already explained you. So this is how the ray diagram is. You can see real and inverted images formed and smaller in size. Okay, now this is an important case. Let's discuss this. When the object is at C, beta, whenever the object is at C and we have a concave mirror. Now see, very very important thing is missing here. What is that? It is the polishing of the mirror, my dear students. If that is not there, remember, again I'm repeating the same thing, then the examiner won't give you any marks. So this polishing, this is the reason why I have not done it, and now I am doing it to show you. Okay, if you will do it like this without this silvered surface, showing this surface as silvered one, you won't get marks. Okay, you need to be very careful that these rays must be, this particular should be drawn. Okay, even if the ray diagram is completely correct, the examiner cannot help you out. They won't give you any marks. Even in the board exams, 10th class, we deduct it. So this you need to do very carefully and correctly. Okay, so this is what it is. Once that part is done, the ray diagram is complete. We can see when the object is at C, first ray is a line parallel to principal axis, so it will pass through the focus. We can see this is the point F. This is the point F. Okay, so what will happen here? Yes, at F point. Yes, if the incident ray is a line parallel to principal axis, if the incident ray is a line parallel to principal axis, then in that case, it will pass through this point focus. Now second ray, just the opposite. If the incident ray is a line passing through the focus, it will emerge out, it will get reflected as a line parallel to principal axis. Now let us see where the two meet. See students, this is the point where the two meet. And what we can actually conclude here is that the image formed is of the same size, it is inverted, and it is real. The image formed is same size, inverted, and real. So that needs to be taken care of. Okay, let us move to the next. Now when the object is at infinity, if that is the case, now here you can see this is a concave mirror, polished properly. Okay, P, F and C are the points. Now when the rays are coming, say, from sun, all the rays, when they are coming from the sun, they will all come as parallel rays. Okay, incident rays will be line parallel. So what will happen in this case? They will all pass through the focus. Now since this is how the rays are falling, at this point, how will I draw the normal, students? Do we know? Yes, we will join the center of curvature. We will join the center of curvature with the point of incidence. You will draw the straight rays. Okay. Yes, dotted. Why am I drawing, beta? Can you guess? Yes, because we know that this is not a ray. Okay, this is not a ray. So you will draw the normal. Now which law will you follow? You will follow the rule angle of incidence is equal to angle of reflection, because laws of reflection will be followed. So these two angles will be same, and it will go like this. Same is happening with here. See here the normal is already this principal axis. This is the incident ray. Okay, this is the incident ray. So what is happening? Again, we will draw the normal. That means we'll join this point of incidence with the center of curvature. Now, using the same angle of incidence, we'll draw the second ray, and this is how it emerges out. The point where the two meet, that means in this case, the image formed. In this case, the image formed will be at focus. So be very clear, when the object is at infinity, image is formed at F. It is real because it is on the same side as that of mirror. It is inverted, yes, upside down it is, okay, and smaller than the object. Of course, the rays are coming from infinity, so the object is bigger in size and the image formed is diminished, we can see. Now let us see the next. When the object is between F and C, I have just now explained you. Okay, see, when the object is between F and C, first ray line parallel to principal axis, it will pass through the focus. Second ray, let it be a ray passing through the center of curvature. So it will just be with the opposite arrow, you will show that will remain the same. So when I produce the two, when I just see the two, they meet at a point here. That means whenever the object is between C and F, the image is formed beyond C. This is the point C. Image is formed, we can see beyond C. Image formed, is it real or virtual? It is real because it is on the same side. Inverted, yes, upside down, and it is larger in size. So needs to be prepared very carefully. When the object is at F, I've already explained you. So all the ray diagrams must be drawn. Okay, students. So this is what it is. All of you prepare well and complete well all this work. In the next class, I am going to take the further topic. That is, we will talk about the ray diagrams related to concave mirror. Convex we have discussed. In the next class, we'll talk about the ray diagrams related to convex mirror. Okay, and the users also. Up till here, all the ray diagrams must be drawn properly by you all. Thank you, students.